Yes. Hi everyone, I am SS Kiran. I would like to discuss about a few biasing circuits by using BJT and FET in the Proteus software. Okay. Before going to this discussion, first create a new folder in any drive or any folder. Okay. Click on new folder. Okay, biasing circuits, this is our folder name. You have to map this respective folder. Okay, now double click on this Proteus 8 professional. See here, observe carefully. Double click on this Proteus 8 professional, then click on new project. Okay, then go to browse and map the respective folder. Okay, EDC experiments and biasing circuits, then select folder. Then right here before dot, some experiment name is biasing. Experiment name is biasing underscore circuits. That's it. Then go click on next, finish. That's it. This is our Proteus 8 schematic capture window. Little bit zoom. Okay. Now we'll go to our circuit diagram. Okay. Our first circuit diagram is collector to base biasing circuit. We have several circuits are existed. First, we'll go for collector to base biasing circuit. In the circuits, our required components are transistor, a resistor, at the same time milliammeter, microammeter, and voltmeter, 12 volts battery or V source. Okay, now select one by one component. First, I will go with component mode. I will show you. This is the component mode. Then click P. Then start typing BC107. Okay, this is our required transistor, BJT, bipolar junction transistor, right? BC107. I have placed it here. Then next one is resistors. I can select resistors, RESISTOR resistor. Resistor is also available. Resistor, just you can select this resistor. Resistor you can keep in this at the base, and you can keep at base. Okay, then you can you can rotate like this. Okay, as per the circuit diagram, you can keep here. Then one more resistor, you can keep resistor here also at collector side, then rotate like this. Okay, then slightly drop like this. Resistor is also placed. Then I will go with the battery, BATTERY, battery. This is battery. Cell, battery or cell, both are same. Okay, or this is also okay, no problem. Battery, this is cell, no issue. You can take any or B source, no problem. Just you can place at top of the circuit. Okay, that's it. All components are placed. Now I would like to take instruments also. Then go to this virtual instruments mode. Right, in this virtual instruments mode, I want DC voltmeter. Yes, I would like to keep here DC instruments mode. Then I will keep here for calculating the VCE voltage and VBE voltages. Then I want collector current also. I have placed here. This is for collector current. Okay, this is for collector current. Then I would like to rearrange the components by using this one. Okay, now this resistor, just scroll up. Okay, this battery also better to scroll up. Okay, now okay, actually this is voltmeter. I don't want voltmeter, I want DC ammeter. Keep here DC ammeter. Just that's it. This is DC ammeter, right? Next I would like to connect one more ammeter here. This is one more ammeter, right? Okay, fine, 100 kilo ohms, right? All instruments also placed. Now I start connecting one by one. Okay, so this is mm, battery positive. This is connected to negative like this. Okay, this positive is connected to like this. Next, this positive is connected to here. Okay. Then next, this is connected to base bias means this base is connected to this resistor like this. Okay, and this resistor is connected to base indirectly as shown in the circuit diagram. Now I will take ground also from this terminals mode. See, observe this terminals mode, then click on ground, then keep here, this is ground. Now start connecting this ground also. First you connect this voltmeter, then connect this ground. The symmetry is also connected to the ground. Voltmeter here negative is connected with also ground as shown in the as per circuit diagram. That's it. Circuit is ready. One more ground is also important here in this place. Simply you can connect this ground also. That's it. Now change the values as per the circuit diagram. First of all, this is 1 kilo ohm. This is 1 kilo ohm, right? Then battery is 12 volts. Battery is 12 volts. By practice, you will get this knowledge. Okay. Base resistor is 100 kilo ohms. Base resistor is 100 kilo ohms, right? Here, one more important thing is IC is the milliampere current, base is the microampere current. This is very important thing. Double click on this ammeter, then change this amps into milliamps. Okay, then click OK. This base current is very small. This amps is converted into a microamps as shown like this. Okay, then click OK. Rest of things are same, no more changes are here. That's it. Now this is the collector to base biasing. Simply you can simulate the circuit and note down the values. This now I will start simulating. Now this is the simulation button. Very simple. Start simulating. Okay, see the values, very important values. Now, just you can write these values first here. IC is 7.85 milliamps. 1 second, I will mention here text here by using text component. This is the IC value. I would like to change 1.5. This is the IC value. This is the VCE value. This is the VBE value, right? This is the IB value. Then simply I can rearranging the things here with the help of this selection button. Okay, this is IB and this is VBE. Okay, this is VCE and this is IC, and here this is VCC. Okay, I will note down this is VCC. 1 second, this is okay. Better you can change this one by using this battery symbol also. Just you can write VCC. That's all. Now start simulating. Now note down the values for collector 2 base biasing circuit. IC value is 7.85 milliamperes. VCE value is 4.12 volts. IB equal to 33 microamperes. VBE equal to 0.73 volts. Okay, that's it. This is all about BJT biasing circuit. You can design any type of circuit, but just you can do your own way. Just take some screenshot this one, and you can design your own way. And this is the constant base bias circuit. Okay, now just you can design your own way. Please take screenshot by using with the help of above circuits. You can design this one. Okay, I will little bit zoom like this. This is the base by constant base bias circuit. Please take screenshot, right? Now I will go for another interesting circuit, that is FET biasing circuits. Okay, FET biasing circuits. Another circuit is also available. Interested students can take screenshot this one also for designing the another circuit. This is the voltage divider circuit. Yes, you can rearrange the components and note down the values. That's all. You can take screenshot for this picture also, this circuit diagram also. You can design this circuit in this Proteus software. Okay, now I will go for another interesting circuit that is called self-biasing circuit using FET. Okay, directly I will go to the circuit diagram. This is the circuit diagram. I won't change much in my original circuit. This is the basic circuit. Okay, simply I can modify the circuit accordingly. Then first of all, I stop the simulation. Then I will remove this transistor, I mean this BJT. Okay, then I will go to the component mode. I will go to the component mode. Then go to the pick. What is our 1 second? I will check whether the number 2N3922, 2N 2N3922. This is our N channel FET. Good. Just simply keep here our N channel FET as per circuit diagram. Okay. In this voltage is fixed, current is fixed. Here there is no drain to gate. Okay, then simply I can remove this wire with the help of right click and delete this one. Right, and no need to here connect this here microammeter, not required here. Okay, resistor is okay. Resistor is, I will go with 70 kilo ohms. I will modify the value, no problem. Okay. Right, next, one more here, one more interesting component is also connected here, that is resistor, that is for source resistance. I think this is source resistance. Now just click on rotate clockwise, just simply place in the respective position. That's it. Everything is perfect. Right, then start connecting and start connecting like this. Okay, this is also fine. This is also fine. Okay, right, and this is also okay. Good. Okay, now here the one important thing is we have to change the parameters. This is not VCC. This is VDD. Okay, this is not VCE. This is, I think, VDS or VST, no problem, VDS. This is not VBE. This is VGS. Yes, exactly. This is VGS, gate source voltage, right? And one more here, important thing is parameter. This is not IB. Remove this one. This is not IC. This is, I think, this is ID. Okay. Uh, Everything is okay, then start connecting like this. Here uh, first just you can 1 second, right, just arranging placement is very important. Just keep away from the screen, just modify like this. Okay, right, then this ground is keep somewhat, this placement is also very important. Okay. This VDS is connected like this. Delete. Now I connected this one like this. Okay. This plus minus and this voltage source I will connect like this. Okay. That's it. So circuit is ready. As per circuit diagram, I have connected like this. Here, one more interesting thing is VGS is the negative voltage. Okay, then first you can, first of all, you can remove these wires. You can remove these wires. First remove these wires. Okay, change the axis. I will show you how to invert this one by using Y mirror. It is changed. Okay, the rest of things is same, no problem. Okay, rest of things is same. Connect like this. As per circuit diagram, I have connected everything plus minus minus plus plus minus. Here not 1K, here 4. 7 volts, 4.7 kilo ohms, sorry, 4.7 kilo ohms, right? 12 volts is okay. The R1 is here, gate resistance is 70 kilo ohms, 70 kilo ohms. Then here R2, here some source resistance is 1 second. I will see once again, 3 kilo ohms. Here this is 3 kilo ohms. Good, 3 kilo ohms. Okay, right. VDS is okay. Everything is okay. ID is okay. Ground is okay. Yes. Now circuit is ready. Now start simulating in a simple manner. Now this is our simulation button. Run this simulation. You will get the values VGS, VDS, and ID. 1 second. Okay, no problem. Just you can ID you can place here. Then it is good as a designer. That's all. Then start simulating. Yes. Now these are the values. These are the values. Actually, there will be very less gate source voltage because it's connected as a reverse bias. Okay, there is no gate source voltage. If there is no gate current also, once if you give if you give the voltage, it will show some value. Okay, anyway, VDS equal to 9.9 volts, ID equal to 0.43 milliamperes, depends upon the requirement. You can vary the values, you will get various values. If you give the VGS supply also, you will get some value. Okay, and these are some basic biasing circuits. You can design like this n number of basic circuits. Okay, with the help of this discussion. Right, thank you so much. Keep watching. I will update more number of videos. Okay, thank you so much. Bye.